Viewers, welcome to another video on control charts. As we have seen in our previous video, control chart for attribute data, especially binomial distribution, that is the data that deals with discrete binary data. So there we have seen P chart. P chart we have seen for fixed subgroup proportions as well as the varying subgroup proportions. In this video, we will see another alternate chart for the same kind of data, proportion data, but this is not drawn on proportion, but it is drawn on number of defectives. So this chart is NP chart. So let's get into this video and understand about NP chart. As I was explaining, NP charts are drawn for binomial distribution. So binomial distribution is nothing but when you pick up a particular unit, inspect it, you can either call it good or bad, yes, no, pass, fail. That kind of data is discrete binary data, and discrete binary data follows binomial distribution. So let's get into the example and see how does this chart works. So I have taken the same example that I used for my proportion chart, which is pre-chart, where number of bulbs getting inspected on a daily basis and how many defects that we have identified. One thing that I want to make it clear at this stage of the video, the NP chart can only be drawn for samples which are not varying on every subgroup. That means your subgroup size should remain constant. If your subgroup size is varying, definitely you have no other choice but to represent your data in terms of proportion only. So you have to go to P chart only. Whereas if you have a fixed subgroup, then you have a choice of either representing your defectives in terms of proportion or in terms of number of defectives identified. You have both the options. You can either draw a proportion chart for fixed subgroup or you can directly draw a NP chart. But in both the charts, your y-axis is going to change. In your P chart, your y-axis is proportion. In your NP chart, your y-axis is number of defectives identified, which you will identify in some time or which you will understand in some time as I get into this video. So in this video, the first thing that we have to calculate is proportion. So how do we calculate proportion? 5 defects identified out of 500 units sampled or inspected. So here I have individual proportions. So these are individual proportions for the given sample data. Now I want to know the P bar, which is nothing but in this formula, the P bar represents historical proportion of the process. So here the historical proportion is nothing but the average of proportions that we already have. So I'm going to say is equal to sum of all proportions divided by count of proportions. So this is my historical proportion. So I'm going to just refer this value for all my cells. Now I need to calculate the central line for this NP chart. As I was explaining, P chart, your y-axis is proportion of defectives, whereas in an NP chart, your y-axis is count of defectives. It's number of defectives. So here your central line will be average of defectives that we have observed. So I say sum of all these individual defectives that we have identified divided by count of all the individual defectives that we have identified. So 6.92 is the average defectives that we have identified in this example. So I'm going to refer this particular value across my table for all the cells. Okay. Now once this is done, now we come to the upper control limit and lower control limit part of our control chart. So the formula for upper control limit is NP bar, which is nothing but average of number of defectives that we have observed. So NP bar, what we have here, plus 3 times of square root of NP bar multiplied by 1 minus P bar. And as I told, P bar is nothing but the historical average proportion of our process. So that's what I have already calculated and kept it in the column D. So the formula goes like this. So NP bar plus 3 times of multiplied by square root of NP bar multiplied by 1 minus historical proportion of defects, which is my p bar, which I already have here. So let me close the first bracket and the second bracket, the square root bracket. So this is the upper control limit. Now, as we all know, lower control limit, we can just copy the formula, paste it here, make the plus sign as minus sign. But the only thing that we also should do in Excel is to guard against the negative value, because you cannot have negative value as control limit for number of defectives identified. So what we are going to do is we are going to say max 0 comma the function value or the formula, and we will close this bracket, so that if at all there is a negative value, we will get 0 as our lower control limit. So let's have it in the same number of decimals. So we will keep it in 4 decimals. Now let's copy paste this. So we calculated the NP bar, which is average number of defectives, and for that we have calculated the upper and lower control limits. So now what we can do is we can select this value, which is going to be our graph variable. Then this is going to be our center line. This is going to be our upper control limit, and this is going to be our lower control limit. I select all these 3 options. I go to insert, I go to graph, I select this graph, I get a graph like this. So we can call it as our NP chart. One major difference between P chart and NP chart is P chart, your y axis will be proportion, whereas in NP chart your y axis will be number of defectives. And one more thing that we need to understand is P chart can be drawn for fixed subgroups as well as various varying subgroup, whereas NP chart can only be drawn for fixed subgroup, cannot be drawn for varying subgroup, because if you start plotting number of defects and if your sample size is going to increase and decrease, then number of defect does not make sense. Then only proportion of defect makes sense. So that is why you can go for P chart with varying subgroup as an option and draw the control charts. If you are dealing with discrete binary data, binomial distribution, however your number of data points and subgroup is not same, it is varying, then P chart is a better option. If you do not have that constraint, you take only fixed sample, then you can either draw a NP chart or you can draw a P chart with fixed subgroup option and draw the chart. Both are possible. Now we will see how to draw the same chart in minitab. So let me take you to minitab. So let me close this graph which I have already prepared. Let me also delete all the previous data points that I have. Let me copy paste these values from Excel to minitab. Stats, control charts for attribute data, NP chart. So here I select my number of defectives as my chart variable and number of bulbs inspected as my subgroup size. I go to NP chart options, I go to test options, I have all my tests for binomial data checked, and I say okay. So these tests are other than the data point going beyond your control limits. These are other tests that we are doing in terms of how many data points, 9 points in a row on the same side of the center point, 6 points continuously in increasing or decreasing direction, 14 data points alternating above and below. So these are all other statistical tests that we need to do for a binomial data. So I've selected that and I have clicked OK, and when I click OK, I get this chart, pretty much the same chart that we have seen in our Excel way. Now we are seeing the same chart in a mini version. So let me copy it and take it to your Excel so that you can have a comparison of both the charts. So let me paste it here. You will find pretty much the same chart being constructed here with the help of minitab. Earlier we have drawn this with the help of Microsoft Excel. So friends, let me quickly summarize. The scenario for us to go for a NP chart is when we are dealing with discrete binary data and data following binomial distribution. And by discrete binary data, we mean a data which can be or outcome which can either be classified as good, bad, yes, no. That's what we mean by discrete binary data. In our example, in a bulb manufacturing company, out of 500 samples picked up every day, they see how many bulbs are defective. So that is what you see in column A and B. And in column C, we are calculating the individual proportion. And in column D, we are calculating the average proportion. In column E, we are calculating the central line, which is nothing but NP bar, which is nothing but the average of number of defectives being identified. And in upper and lower control limit, I have used the formulas, and the formula is 3, that is NP bar plus 3 times of square root of NP bar multiplied by 1 minus average of historical proportion, which is there in our column D. And the same formula, instead of NP bar plus 3 times, here we are using NP bar minus 3 times. So with this, we have drawn this chart in the Excel, and the same data we have used and drawn the chart in minitab also. Friends, I hope this video was useful for you to understand the formula of NP chart, how the data need to be collected, and how the NP chart can be constructed in an Excel file, and how the same NP chart can also be constructed in minitab. Thanks for your time. Thanks for watching. For more videos on control charts, quality management videos, minitab tutorial, please subscribe to our channel. Thank you.